Another option for active reconnaissance during the information gathering phase of an engagement is the use of electronic surveillance or eavesdropping. Now, eavesdropping is the act of secretly or stealthily listening to the private conversation or communications of other people without their consent in order to gain information. This can be conducted using non-technical means through social engineering or technical means using technology. For example, maybe I know that the system administrators like to go to the bar at 5 o'clock every Friday afternoon after work. I can simply go to that bar, grab a drink, and listen to what types of information I could gather by eavesdropping onto their conversations. Alternatively, I can also conduct eavesdropping using more technical methods, such as placing a network tap on the organization's WAN connection, conducting an on-path attack to reroute their traffic through a proxy server or rogue wireless access point that I control, or even joining their wireless network and setting my wireless card into promiscuous mode, which would allow me to collect all the traffic as it's passing through the air. In technical eavesdropping, our goal is to try and capture the information from the data packets as they're crossing the network or passing across the internet. Remember though, you have to check if eavesdropping is within the scope of your engagement and has been agreed upon by you and the organization before you conduct it. If it is within the scope of the engagement, then by all means, it would be a valid technique to use. Wireless devices of all kinds are also great targets for eavesdropping if you can get close enough to the facility or an employee with the device outside of their office. By using specialized equipment to capture radio frequencies, a penetration tester or an attacker can capture data from cell phones, wireless devices, Bluetooth devices, near-field communication devices, and other sources. Then, they can attempt to crack any encryption used that protects those devices, and if they're able to do that, they can then analyze the information that was transmitted because they now have it captured. Now, capturing cell phone communications is probably not something you're going to do as a penetration tester unless you work for the federal government or the military, but it is considered a valid penetration testing technique and a valid attack technique because attackers usually don't care too much about the law. These frequencies may be captured right out of the air, and depending on the quality of your antenna, you can actually capture that without being that close to the actual target. Now, if we have a really strong antenna, for example, we might pick up the signal from a further distance away, but we're still going to have specialized tools to turn that scrambled or encrypted data into usable information. Now, in addition to capturing the frequencies, a more common type of eavesdropping is known as network traffic capture or packet sniffing. This involves capturing all the data packets that were sent over the targeted network and then putting them into a file. Packet sniffing attempts to intercept and log all of that traffic from a wired or wireless network. And if you're able to gain access to a host computer during your initial foothold of your attack and exploitation phase, you can actually turn that computer into a network sniffer for you by using utilities inside of the Metasploit framework to further your enumeration of the network and gain additional access to conduct lateral movement. Now, as you're going to find out, once you enter into phase 3 of your engagement, you're often going to be going back and forth between phase 3 and phase 2, so you can conduct additional reconnaissance and enumeration based on where you're now at with your initial foothold in that organization's network. Oftentimes, our penetration testing methodology becomes very cyclical in nature, and we go between phase 2 to phase 3, back to 2, back to 3, and back and forth over and over again until we reach the end of the engagement and move fully into phase 4, which is reporting and communication. Now, if you're conducting network sniffing, you're often going to use a software tool like Wireshark or TCP dump to conduct the packet capture and analysis. These tools are known as protocol analyzers, and they have the ability to also conduct packet capturing because they are packet capture tools as well. Now, to perform network sniffing, you need to place your network card into what is known as promiscuous mode. This allows the card to capture all the traffic it sees on the network segment and then writes those packets into a PCAP file, which we call a packet capture file. Now, this PCAP file can later be analyzed using offline methods using a protocol analyzer like Wireshark or TCP dump, so you don't have to do this all in real time. A protocol analyzer is just a specialized type of software that collects raw packets from the network, and these packets are then analyzed, which can be helpful for troubleshooting network connectivity issues if you're a network engineer, or for assessing security if you're a penetration tester. Now, when capturing this raw network traffic, the sniffer is going to not transmit any data back into the network, and so it makes it really difficult for network defenders to see us and detect us. This is really a passive thing when we're collecting the data, but we put it under active reconnaissance because to gain access to that network to install that sniffer was an active activity. Now, in order to protect the data as it moves across the networks, most network defenders and system administrators are going to utilize encryption techniques to protect the data in transit. If they fail to do that, then it makes our job as a penetration tester or an attacker really easy, because we can easily read that information from the packets we captured using Wireshark or TCP dump. Now, many different protocol analyzers are available out there, but again, the most widely utilized is Wireshark, and it has a graphical user interface that can be used to capture packets, analyze those packets, and identify the desired information if it was unencrypted when it was sent. Even some forms of encryption can be decrypted by Wireshark too if they're vulnerable to exploitation, like some of the older versions of SSL are. During an engagement, protocol analyzers can be used to help prove or disprove statements that were made by system administrators. For example, maybe you're conducting an audit and the administrator claims that certain types of network traffic is encrypted. Well, you can easily verify whether or not that's accurate by conducting network sniffing and analyzing the captured packets. If it's not encrypted, you're going to be able to see everything, including usernames and passwords, really quickly. Now, if our target is using a hub on their network or the organization is running a wireless network, we're going to be able to see a lot of information going across that network and be in a great position to capture it. If we're using a switched-based network, though, those switches are only passing information to the designated ports based on the MAC addresses. So we're only going to see what is going to and from our computer. Now, if this is the case, we have to connect to a wired port that's configured as a span port or mirrored port in order for us to be able to see all the traffic in that wired network. Now, if we can't find a span port or mirrored port, then we're going to have to conduct a network attack to overload the CAM table of that switch and force it into promiscuous mode. But this is obviously more noisy and much easier for a network defender to catch. Wireless networks, on the other hand, are much easier to perform packet capturing on because we can connect to them, we can then capture everything they have because they're operating like a hub and they rebroadcast all that traffic to the entire network segment. To break into one of those networks in the attack and exploitation phase, you're going to use tools like AirCrackNG, which is a wonderful suite of tools that can help us break into WEP, WPA, WPA2, and WPA3 encrypted networks. As soon as we're in that network, we can then start capturing all the packets and then harvest a great deal of information from it. Now, you may be wondering, if I'm capturing encrypted data into a packet capture, that's pretty useful if I can decrypt it. But what if I can't? Is it still useful? Well, the answer is sometimes. This really depends on your goals during the engagement. But just because the data is encrypted in the payload doesn't mean that the packet itself is useless. The encrypted data still has a lot of useful metadata in the packet header, and we can identify things like the source and destination IP addresses, or the source and destination ports, the type of protocols in use, and the volume of data being sent. All of this can be captured as we're doing our packet captures, even if the payload has been encrypted. For example, let's say I captured the network packets over a 7-day period for a given organization during an engagement. Even though the contents were encrypted, I can still learn a lot about that organization. I may see there's a large volume of data that's leaving the organization's network every evening from 1 a.m. to 4 a.m. I can see the IP address that the data was sent to, and I can look that up and figure out maybe it's owned by Amazon Web Services. This now tells me this organization might be conducting offsite backups to their cloud provider every night between 1 a.m. and 4 a.m. Similarly, if I see a lot of VPN traffic going from their headquarters to another location, I can identify potential areas for attacks at those locations too, based on their IP addresses and the ports they're using. Those locations might be branch offices, and as I've said before, branch offices tend to be less secure than the headquarters building, so it may be an easier way for you to break into the network. When we collect these encrypted types of information, another thing we can use it for is to build out a flow analysis. This helps us identify the resources and servers that are communicating with each other and what types of devices or locations they're communicating with. The benefit of flow analysis is that it allows us to highlight these trends and patterns inside of the network traffic. We can also set up alerts based on anomalies that we detect based on different patterns and triggers as they're being observed. Flow analysis can also use visualization tools to quickly create maps of different network connections and their flow patterns, as well as to highlight any abnormal traffic patterns that might reveal data exfiltration by another attacker, malware beaconing by another attacker, or other maladies. A tool like NetFlow can be used to conduct flow analysis, and it's going to show you the metadata and visualizations for the captured traffic, even if those packet contents were encrypted. Remember, flow analysis is focused on metadata, but protocol analyzers can actually look into the packets and see the data they contain. This makes protocol analyzers exceptional tools for finding insights into HTTP sessions by extracting files contained within those sessions, identifying malware connections to remote hosts, identifying vulnerable versions of software, finding evidence of brute force attempts, and much more. You can even capture all the API requests and responses that are being sent to and from a vulnerable web application by doing this packet capture too.